Okay, here we go. So I'm going to do something different today, and I'm going to confess at the very beginning that I'm now talking outside an area that I have any plausible claim to expertise in. This is something I've been studying a little bit and trying to come up to speed on, and that I wanted to speak with you about, not because I'm an expert of any sort in it, but because I know it's on all of our minds, and because it's worthwhile, I guess, separating what's fact from fiction, what's rumor from what is perhaps a genuine concern. And so what I'm going to speak about today is the coronavirus, and in particular, mutations and vaccinations, and whether we're beginning to see light at the end of the tunnel, even though we don't know how long the tunnel is or how far that light is away from us, or whether the new developments are things that give us pause for concern. And I'm going to talk about the medical science side of it, but I'm also going to talk about the public health side of it. And in a sense, try to make the case to you on the one hand that we can't really separate the politics from the public health, that this is one of those problems that depends not only on scientific and medical advances, but also on the behavior of everybody around us, our leaders, but also those of us in our day-to-day lives. I'm also going to try to suggest to you that we should not be too worried about the mutations that seem to have taken hold in Britain. On the one hand, we don't know that those mutations are more dangerous, right? And we also don't know that they're not. And so it's appropriate that we be cautious, but also appropriate that we not be too alarmed about them, especially thinking in terms of personal security. And in addition to that, I'm going to try to suggest some of the public policy responses we should be thinking through in an atmosphere in which the virus is changing, as it does really quite frequently. It's the nature of the beast itself. Before I get into that, I do want to spend a few minutes talking about what happened in Washington this week. And this is just repeating things I've already shared with you to give you a little bit of background. We've lost 10 million jobs, right? These are the numbers from November. I suspect it's about to get worse than that, not better than that, in part because the holiday rush is over, in part because the virus is absolutely raging in the country. And this is not just 4 years worth of job creation erased very suddenly. It is increasingly people who are out of work for half a year or longer, and that makes it much more difficult for them to come back into work, and people who are simply leaving the labor force altogether. And those are things that can have long lasting negative impacts on the economy, on the productivity, on the wealth, on the well-being, economically speaking, but of course psychologically as well, of average Americans. And what we know, and it's particularly important to note this in the holiday season, there are tens of millions of Americans who are going hungry, who are facing possible eviction or foreclosure, who desperately need our help. And while we can help as individuals through charitable giving, activism, volunteerism, we need our government to help them as well, right? That's just a different order of action when the government distributes assistance. And unfortunately, what happened this week, or is happening today actually, is that almost all of the aid that has been distributed to American families under the CARES Act, which was passed in the spring, has now expired, right? And last time I showed you this graph, this list, right, it was expiring on 12/31. But the fact of the matter is that because 12/31 occurs midweek next week, all of these programs will no longer distribute benefits as of today. So the $600 per week was gone in July. That's a supplemental unemployment benefit. But the programs that gave workers in the flexible or gig economy benefits, the extension of unemployment benefits for an additional 13 weeks, the aid that was given to states who, of course, fund and distribute unemployment insurance, the Treasury Department's ability to back the businesses and small governments, state and local governments, and the moratorium on residential evictions have now all expired. And of course, there was legislation that passed both the House and Senate and went to the president's desk at the beginning of the week. And this was not great legislation. I like the way that Joe Biden expressed it in terms of saying that this legislation is nothing but a down payment, right? That it did not have enough in supplemental unemployment benefits. The evidence is very clear that the money that is given in supplemental unemployment benefits very quickly makes its way back into the economy. It keeps people from being hungry, from having to skip medicine because they can't afford it, from losing their homes or their vehicles, right? It does immediate, concrete good, both to the individuals who receive it and to the economy as a whole. There was only about 10 weeks of that in this legislation, and it was at a relatively ungenerous level. There are other problems with this legislation. But on the other hand, you know the old Bismarck saying, if you legislation and sausage are the two things you don't want to know how they're made. And obviously this legislation was the product of a long, protracted negotiation between two parties that really do not work well with each other right now. And so it took 6 months. It took the Republicans coming up from 500 to 900 billion. By the way, that makes it essentially the second most expensive piece of relief legislation ever passed in the history of the United States. We shouldn't diminish that. It's bigger than the relief legislation that was passed in the 2008-2009 recession. And of course, the Democrats came down from 3 trillion to 900 billion. There was a lot of give and take in this negotiation. This was not the end of this process, but it was an important effort to make sure that new aid got out to people who desperately need it. And then, of course, on Tuesday evening, Donald Trump, the president of the United States, posted a video objecting to the $600 payout in stimulus money that all Americans will get under this legislation as being too small. Now, it's worthwhile remembering that the figure of $600 for that stimulus payment came from Donald Trump's own Secretary-Treasurer Mnuchin, right? And so this was the Trump figure that the congressional leaders coalesced around. And then at the very last minute, when the legislation is coming to his desk, Donald Trump objects to it. And I want to be clear about this, right? I might, in principle, agree with Donald Trump. I've already told you that I think the unemployment benefits are more important than the stimulus payments in terms of how they affect the most needy and also how they stimulate the economy. They tend to enter the economy much more quickly. But nevertheless, I might agree that this is imperfect legislation and that it would be better if it contained more in stimulus payments. Donald Trump is not objecting to the details of this legislation. And frankly, had he been focused on the details of this legislation, he could have had plenty of influence over it in the last month when the negotiations were transpiring, especially in the last week. Donald Trump is, by all accounts, exclusively focused at the moment on the fact that he lost the election, which he clearly did, on desperate efforts to overturn that outcome, which will fail, and on his sense of grievance and betrayal that he has been rejected and that his efforts to overturn or alter the outcomes fell short. And of course, it's not an accident that in the week before Donald Trump, at the last minute, threw a wrench into the works of these negotiations. The week before, Mitch McConnell, after the Electoral College finally voted to make its outcome clear, right? Trump lost, Biden won. Mitch McConnell took to the floor of the Senate and congratulated President-elect Joe Biden. The week leading up to this legislation, Mitch McConnell made it absolutely clear, again, that the legislation needed to pass because if it didn't pass, the Republican chances of holding on to the Senate would be diminished because Republicans were, quote, being slaughtered in Georgia for their failure to pass this legislation, and the public perception and what was being used by the Democratic candidates in the runoff election to determine the fate of the Senate. The Democrats were campaigning against the Republican Senate's failure to act on this legislation. And so Donald Trump decided to punish Mitch McConnell and other congressional leaders who have not on his account done enough to stand up for him, i.e. to help him steal an election he lost. And I think, frankly, when we do the history of this period, and you will well know that I don't think highly of Donald Trump, that his last 2 months in office may be the most disastrous, the one that historians really focus on, between the damage that he does to the electoral system by spreading wild misinformation to discredit the chief instrument of American democracy, to the damage that's done to the economy by not focusing on and delaying this legislation, and perhaps most importantly, to the human cost of the failure to focus on containing the spread of the coronavirus as it breaks all records. This is an abysmal failure of leadership, and it is self-indulgent, self-pitying, mean-spirited. And so obviously, this is bad news for the country, that the president, who is only thankfully president for another month, is not focused on the urgent needs of the country, and in fact doing damage to what we most need in order to air his own personal grievances. Having said all of that, I do think there's blame to go around here, and some of that blame falls on the Democrats' shoulders as well. And as you know, Nancy Pelosi, the House leadership, tried to get a unanimous consent measure through Congress to bring the stimulus aid up to $2,000 to meet the president's demand. And frankly, she knew, they knew, before they ever started, that there was not a snowflake's chance in hell that this was going to succeed, right? This was purely a political publicity stunt. This was an effort to give some ammunition back to those Senate candidates in Georgia. And I don't disagree. It would be a good thing if the Democrats actually won both of those seats and were able to legislate effectively as a result. But this was too important. The stakes are too high for the country to basically turn it into a strategic football. The fate of aid to hungry, vulnerable Americans in the middle of the coronavirus winter. And so, to be clear, had Nancy Pelosi really wanted $2,000, she could have said very clearly, President Trump says he wants it. His party is the impediment. He needs to work on his party to make them come round. But she should also have said he can't do that with this legislation, right? This legislation has already gone through the process. We have more time. Pass a second bill that ups the stimulus payment to $2,000. We'll work with you on that. But pass this bill now to keep people fed and housed next week, right? And what she did, what the House leadership did by turning this into a publicity stunt is give Donald Trump cover, right? All of a sudden, Donald Trump and Nancy Pelosi agree. And so Donald Trump's intervention is not seen as what it is, this incredibly petulant response to McConnell. We need to keep the pressure up on Trump to sign this legislation. And what the Democrats did failed to do that. So the last thing I want to say is we are in limbo at this moment. This legislation is waiting with the president for his signature, and we don't know whether he will sign it. He has another roughly week before his failure to sign it amounts to a veto, and it's highly unlikely that the House or the Senate can override his veto on this issue. So absent Donald Trump's signing legislation he has now publicly criticized, we may not get further aid until Joe Biden is president. And that means a terrible month of desperation, hunger, vulnerability for tens of millions of people because of the failure of leadership on both parties' part in the United States today. All right, so I will stop there with the
David?
politics. And okay, give me one moment. Yeah, I think I recognized a voice, but I'm going to unmute everyone. Somebody have a comment on the political stuff?
Yeah, it's my understanding that the pocket veto, which is he simply doesn't sign it, and it expires, and I'm not exactly sure when, cannot be overridden, as opposed to a direct veto, which can be overridden. The pocket veto cannot.
Interesting. So that may be absolutely right. It sounds right to me, but I had not done my research on that question. So I will defer to you on that one. I was going to try to Google it. Give me 2 seconds. I think I can figure this out.
I don't know what a pocket veto is.
So a pocket veto is a veto that is not a direct veto. In other words, the president doesn't say, I veto this legislation. He just refuses to sign legislation within 10 days after Congress has adjourned, right? That's a pocket veto. And you're absolutely right. According to Senate.gov, then the president does not return the bill to Congress because it's a pocket veto, so Congress does not have the opportunity to override it. So yes, the bill is either signed by Trump or it is dead. Thank you, Bob, for pointing that out. Anybody else with a question about the politics of this moment? Okay, I'm not seeing anyone. I'm going to go ahead and mute everyone again. Remember, whenever you want to interject a question, please do. Just hit your space bar. I've left it so you can unmute yourselves. Let me go right back into the presentation. And now I'm going to do something I don't usually do. I'm going to start talking about something that I don't have expertise in. And as you've seen, even stuff I have expertise in, sometimes I need some help. So if you have more information to add, please do it. I'm going to start just with the basic trend lines on the virus. And as you can see, right, the prediction that there would be a post-Thanksgiving spike as a result of extensive travel and indoor get-togethers for Thanksgiving. did come to pass, and we've seen absolute record levels. We're breaking all records in terms of per capita rate of transmission or fatality for the world, right? But the good news is that this is finally crested and has started to come down. Of course, deaths and hospitalization are lagging indicators. They come on 2 weeks after the virus is contracted, and so we may not have seen the top of the mound with deaths and hospitalization. The bad news in all this is, of course, last weekend, we saw more air travel than we've seen at any point during the coronavirus in the United States. 3 days in a row in which 1 million people or more were traveling. And that means, unfortunately, that it's very likely we should expect another and perhaps still higher peak to be coming in the middle of January. As you can see, the coronavirus is everywhere in the country. This map gets darker or brighter each week that goes by, and there are places like Tennessee, Mississippi, Arkansas, Oklahoma, Arizona, much of Southern California, where the rate of transmission is just totally uncontrolled. And so this is obviously not a happy picture that we're looking at. And I think perhaps just to underline how grave the problem is right now, this is the rate of hospitalization in the United States. And as you can see, there are more than 100,000 people in hospitals per day. And you don't get admitted to the hospital unless you are gravely ill with this disease. And in many of these states, in Tennessee and Arkansas and Oklahoma, Arizona, these hospitals are now at capacity, right? They've taken the gift shop and turned it into the waiting room. They've taken the waiting room and turned it into an emergency care facility. They've taken the ER and turned it into an intensive care unit. They have exceeded the physical, human, and infrastructure capacity of the hospitals in important regions of the United States. And this is making things very difficult. Hospitals that don't typically treat severely ill people are having to treat them. People are having to cross state lines when they are severely ill in order to find capacity in hospitals. This is a real problem. And I will say one thing about the British mutation at this juncture, and that is to simply point out, we do not know, so I think it's important to be cautious in saying this, but there is a possibility that the rate of transmission of one of the mutations that is now dominant in Britain, widespread in Britain, it's possible that it is 70% more contagious than the earlier versions of the virus. And if that is the case, and if the British mutation isn't already widespread in the United States, two big ifs, right? For all we know, it's not actually 70% more transmissible. For all we know, it's already here and as prevalent in the United States as it is in Britain. We're not doing the testing to know, the genetic sequencing. But if both those things are true, and there's another version of this virus that's a lot more contagious, we should be hyper vigilant in protecting ourselves from that, because obviously we are already exceeding our hospital capacity in important regions of the country. Now, to the good news, right? And let's start with the fact that of the 80 plus vaccines that are being developed, only one of them has been abandoned. 2 have been approved in this country. There's another one that's been approved in Russia, though I doubt it will be approved here. But there are 18 more that are in phase 3, that are nearing the end of their preliminary trials. There are 5 more that are being approved for early or limited use in certain places in the world. We will soon have more than 2 vaccines, and we can only hope that they come online quickly, that they can be ramped up for production quickly for reasons I will get to. But to just be as clear as possible now, anticipating what will be said later, it's not just having a very effective vaccine. It turns out that the rate at which the vaccine is distributed and the degree to which everyone in a population gets the vaccine matter for the efficacy of the vaccine in containing the virus in that population. So again, to show you something we've seen before, this is for the Pfizer-BioNTech vaccine, and as you can see, highly effective, right? Basically, it's 95% effective in preventing the transmission of the disease. And so you can see the difference in the placebo population in terms of the rate of transmission. Now, this is a new map. This is the first time we're looking at this together, and it's an important map, and it has, frankly, ambivalent information. On the one hand, what you can see is that the vaccine has now been distributed in every state in the country, right? But what you can also see is the percentage of the population of the state that has been vaccinated. And so there are several dark green states where as much as 1% of the population has been vaccinated. But there are more light green states where fewer than 0.2% of the population has been vaccinated. And by the way, the CDC and Operation Warp Speed hoped we would be up to 3% by Christmas. And so we are falling short on the distribution of the vaccine right now. I'm sorry, I think this is the slide I wanted to show you. This makes it a little bit more concrete. We can focus on California, right? Where at present, 1.7 million doses have been allocated, 440,000 odd doses have actually been received, but only 70,000 have been administered, right? And as you can see, those numbers are pretty representative of our other large population states. And so really no state has yet done a good job in administering the vaccine and getting it out. And so this is another place then where politics, ethics, and medical science all intersect. It's not enough for the biotech, the big pharma companies to develop these vaccines. In order for them to work, our government has to be effective at distributing them, and our population has to be willing to take them. And that is perhaps every bit as important as the efficacy of the vaccine itself. And I will just point out to you that administering the vaccine in a large state like California, Texas, Florida, or New York will cost not millions, but billions of dollars. And that among the things that was contained in the legislation that is languishing on Trump's desk is money for the states to assist them in administering the vaccine. Right now, the problem is more infrastructure and coordination. We just haven't developed the bureaucratic or administrative wherewithal to get the vaccine out rapidly, but pretty soon the problem will be financial as well. States will not have it in their budget unless the federal government comes to their aid. And as we're seeing, the federal government is in disarray at the moment. All right, so let me just give a little bit of background as to why it is that in the middle of a pandemic, we're concentrating on developing public health infrastructure when our doctors and hospitals are overwhelmed at coping with the virus. And I gave talks on this 5 years ago when people were thinking about Ebola. We need to spend more on public health in the United States. What these figures show is that from the middle of the 20th century to the end of the 20th century, we consistently spent more on public health. But that beginning in the 20th century, we essentially flatlined, and then our expenditures actually went down. And this doesn't go out to 2020, but the people who look at this believe that we have underfunded public health by probably as much as 20%. And part of what you can see here, right, I know it's a little bit hard to make out the graphics, but this is the percentage of national health expenditure, right? And so as a percentage of overall health expenditure, right? And what you can see is that in the United States, right, our expenditure is a very small fraction of what we spend on healthcare. Almost all of our healthcare expenditures are on private insurance or Medicare or the Affordable Care Act. We spend too little on our national healthcare system, and so we do not have a national system to distribute the vaccine. And this is going to make things difficult for us in the coming months. This, again, is a long-term priority, but it's something that the immediate difficulties of fighting a pandemic should make clear to us. Now, I just want to give a little bit of background on public health expenditure in general and the idea of an epidemiological transition. And what I want to make clear is just how lucky we are to be living in 2020. And obviously it was just the worst year in a century, but we've got to put that in the context of what the mortality rate was a couple hundred years ago, right? People living into their late 30s or early 40s, and how we succeeded through containing disease and famine, right? Those were the big killers, right? With basic increases in agricultural technology, plumbing, sanitation, et cetera, right? And so if you look at what happened to the death rate, right, absolutely plummeted. The birth rate stayed high for a while because people were used to children dying in childhood. And in essence, this diagram is telling you this is where Egypt, Kenya, India are today, right? Starting to bring the death rate down, but the birth rate's still high. So population grows. You then enter a third phase in which you get improved medical care, better diet, in addition to improvements in medical care, sanitation, water supply, et cetera, and you really bring the death rate down. And when you get into phase 4, it's no longer infectious disease that's really responsible for deaths. And at this point, people start to adjust their birth habits. They have fewer children, and so you reach a steady state or maybe even declining population. The US is here. Germany, according to these authors, are here, where the combination of family planning, good health, the improving status of women, later marriages, begins to actually decrease the overall population. All that to say, investing in public health, broadly construed, has fundamentally changed the human lifespan and the experience, the morbidity as well as the mortality, how sick we are, how much we suffer. Life is much better today. But we are moving in the wrong direction in this country. We are spending less and we are living less long lives. And we need to go back to the 20th century approach to supporting public health. Now, I'm going to spend the remainder of today's lecture talking about that British mutation. And this is not my area of expertise. I have drawn on two sources primarily. One of them is a doctor, Dr. Zubin Damania, who gives online lectures. I've been listening to him for about a year now. I don't always agree on him. And he does have the good graces to admit when he's wrong and change his mind. And he admits that he's quite libertarian and that at first he was somewhat skeptical of some of the public health measures that were being advocated, like business closing. He has since changed his mind on that. But I think on the core medical science stuff, he really understands it and explains it well to someone like me who is not steeped in this stuff. And then I've also read recently Matt Richtel, a Pulitzer Prize winning New York Times journalist, a history of the advances in understanding of the immune system and then in using that understanding to produce new medical advances that have occurred almost entirely in the last 100 years. He goes back to the 17th century to look at the roots of this when we first discovered that there were not just red but white blood cells as well, but he really concentrates on 20th and 21st century developments. So let's start with the coronavirus and the British mutation. And this is a coronavirus, and I think two things to note. One of them is that it is covered with protein spikes, and it actually uses these protein spikes to penetrate and enter other cells in the human body. And as you know, with a virus, the virus can't reproduce itself. It essentially hijacks the mechanisms within an independent cell. This is a subcellular entity. It's a tiny little thing to piggyback on the processes within a cell in order to be reproduced. To do that, it has to invade the cell. And the coronaviruses use these protein spikes. And then this is the genetic code. It's RNA as opposed to DNA. That just means there's a different sugar, slightly different processes. And this diagram in particular focuses on what the sequence in the RNA that produces the spike protein. And that'll be clear why it does that when we get into the vaccine. Now, the way in which the coronavirus works, it gets inside a cell, it takes over that cell, it hijacks the reproductive process, it builds thousands of copies of itself and then kills that cell and then disseminates into other cells of the body, right? What matters most in what I just said is that it reproduces itself thousands of times in a cell, right? And that reproductive process, this is a very simple organism, is not edited or controlled in the way it is in a human being. We have complex processes that check to make sure when we reproduce our DNA at the cellular level that we have done so accurately and that destroy mutations that might have been introduced in the reproductive process. And it's not totally 100% fail-safe, but it's a very effective system of preventing mutations. The coronavirus does not have those systems. And so mutation is typical for a virus like this. We now know that what originated in the Wuhan region of China, the coronavirus, didn't come to the United States primarily in that original form. It went to Europe. It mutated. We closed our borders to China to try to keep it out, but it was already in Europe in a mutated form. We can sequence it and see that the version that really took hold in Seattle and New York and then spread throughout the United States had already mutated. Mutation is normal, typical, to be expected. A lot of mutation that occurs in these viruses, I've learned, actually is not in any way adaptive. It's maladaptive and the virus just dies. And so you don't see that mutation. Much of the mutation, on the other hand, is not destructive, but also doesn't change two key variables: the transmissibility or the lethality of the virus. It basically still is the same beast, even though it's changed its shape or the way it reproduces slightly. But sometimes a virus mutates in a way that increases its transmissibility, right? It makes it easier for the virus to move from host to host because it becomes more contagious. And one of the signs that that's the case is that a new mutation becomes dominant within a population, right? It used to be that there was the old mutation, that's what they had. Then over time, the old mutation dies out, the new mutation takes over. Why? Because the new mutation has an adaptive advantage. It's easier to pass from host to host, and so it takes over. We see this new mutation having taken over in Britain, and from that we can infer that it's at least possible that it's more transmissible. And that 70% figure, that does not come out of a laboratory, right? The way in which we know whether a mutation of a virus is more readily transmitted, is more contagious, is by studying it in a laboratory and comparing. That hasn't been done with the British mutation. We are inferring, people are inferring from its dominance, from the fact that 70% of the cases in Britain now are the mutated virus, that it may be considerably more transmissible, I guess is the word. By the way, there are also mutations in viruses that can make them more lethal, right? That can make them more deadly. There is, as of yet, no evidence that the coronavirus with the British mutation is more deadly. The one cause for concern here, and I should be clear, when I speak of the British mutation, what I read is that there are actually 17 different mutations that are being grouped together and being called the British mutation. And that at least some of those variants, 2 out of the 17, appear to be resilient against what's called convalescent plasma treatment, which is where you take the blood plasma from somebody who has suffered from the disease and give it to somebody who is suffering from the disease in order to assist the body in producing the appropriate antibodies to attack the virus. And it appears that some people in Britain are less responsive. And if that in fact can be to the convalescent plasma treatment, if that can be traced back to the mutation and some advantage the mutation has in fighting the antibodies, then we will be more worried. The third way in which a viral mutation can increase its adaptability is if it overcomes the immunity that a population has developed to it. And in our moment, we are entering the period of the disease, right? The last year has been a period of unchecked contagion because we did not have a vaccine. All we could do was non-pharmacological behavioral changes: social distancing, wear a mask, wash hands, avoid those indoor gatherings, and work on therapeutics, ways to help people conquer the disease once they have it. Now we are entering the era of the transition to vaccination. And as more and more of us get vaccinated, we may get up to the point where it's much more difficult for the virus to jump person to person, because it will jump into people who have the appropriate immunological response, who have been vaccinated. And if the virus were to mutate in a way that allows it to overcome that vaccine and the immunological response that it makes, that would be a huge advantage for the virus. But from what I understand, we don't have to worry about that. And that's very good news, that the kind of mutation necessary to overcome a vaccine usually takes at least 5 years. And what we're seeing in Britain, basically the protein spikes, which is what the vaccine teaches the body to recognize, have to be radically altered for the body not to recognize it. And that has not occurred with the British mutation. So this leaves us with a question: is the British mutation more dangerous? And the answer is, we don't know. Let me back up for a minute, because I've skipped a point that I think is actually very important and interesting. And this is about what we do and don't understand about the virus right now. And there is this distinction, and I'm not positive I'm going to do it exactly right. This is not my field. But the distinction is between what's called R naught and K. R naught, as in 0, right, is the rate of transmission on average for a population. And so if for each person who contracts the virus, 2 more people get it from them before that person either succumbs to the virus or conquers the virus, the R rate, the rate of transmission, is 2, right? This is an average number for the population as a whole, the R number, the rate of transmission. And this is one of those situations where averages are not very helpful. So let me explain that just for a moment. Imagine you wanted to know what the average wealth was in the local coffee shop, right? And so you went into the local coffee shop and you took a survey, and everybody in the coffee shop cooperated. And it turns out that the average wealth of the people in the coffee shop, their homes, their stocks, etc., is 400,000, right? And it turns out that basically everybody in the coffee shop, it's a middle-class coffee shop, is in a fairly narrow band, right? Now, Elon Musk walks into your coffee shop, right? And sits down. He's got a friend there. And all of a sudden, right, the average wealth in your coffee shop is over $1 billion per person. Not because anybody else's wealth has changed, but because Elon Musk is so wealthy that his wealth overwhelms the average, completely alters it, right? And in that situation, you don't want to know the average, right? You need more information. And it turns out that the coronavirus behaves a bit like the coffee shop with Elon Musk in it, in the sense that it turns out that people, on average, don't transmit the virus. We don't understand why. We've heard about super spreader events, right? There's also this term, which I learned getting ready for this, of a super emitter. Someone who, it may be about the way they breathe, it may be about the way they talk. They're really loud and they aspirate a lot when they talk. It may be an intersection of the way they breathe and talk and the environment they're in. They're in that little coffee shop where there's not a lot of circulating air. But it turns out that a lot of the transmission occurs from isolated individuals who transmit a ton. And so they're the Elon Musks of viral transmission with the coronavirus. And that gets us to K, the degree of variability in the transmission. Now, why is this relevant to the British mutation? Because another explanation for why the British mutation has become dominant in London and surrounding areas is just dumb luck, that some hyper transmitters got the British mutation, that they went out to pubs, etc., and caused widespread transmission. And the fact that 70% of the cases in Britain are the mutation doesn't mean the mutation is actually more contagious. It just means it's the dumb luck of the vector of transmission in that case. And so we just don't know. And by the way, I'll get to this more, but understanding that the coronavirus is not like the flu. The flu, that R number is very helpful information. How much the average person transmits is very predictive of how much any person transmits, because there's not a lot of variability in transmission. But how we cope with the coronavirus is going to be different, because many people don't transmit very much at all, and some people transmit at a much more contagious level. So we just don't know if the British mutation is more dangerous or if it's other accidental features of its transmission that account for it being widespread. The implications for the vaccine, again, we don't have to be worried about the mutation for the vaccine. Now, let me talk about the vaccine with you for a few minutes. And I want to start by noting that this is a different kind of vaccine than we've really ever had before, and in important ways, right? So you will remember back perhaps to the polio vaccine. And the polio vaccine was a typical vaccine of basically all vaccines up until the present moment, which is to say they were inactivated or attenuated vaccines. So you take the actual virus and you treat it with formaldehyde or mineral water or oil in a way that you hope renders it inactive, but nevertheless preserves enough of its genetic structure so that the body learns to fight it, right? And I'm going to get into the immune system in a minute, but one of the things that's remarkable about the immune system is the immune system learns, right? And so the whole idea of a vaccine is to give the body a taste of something that would be dangerous if it got the full amount, but in an attenuated way allows the body to learn to react to it without actually succumbing to it. And this was a very imprecise science, right? How much do you have to attenuate the virus so that it's no longer infectious? How much can you attenuate it so that the body still learns from it? You've got to hit a golden mean. And as we know with the polio vaccine, we ended up infecting an awful lot of people with live polio virus, despite the fact that we were only trying to vaccinate them. The vaccine developed by Pfizer and BioNTech and Moderna is a different kind of vaccine. It is a genetic vaccine as opposed to an attenuated vaccine. And so this is, again, the RNA. If you remember back to the previous diagram, it's the segment that makes the spike protein, right? And if you could deliver the RNA of the coronavirus and just that portion of it that makes the spike vaccine into the human genome, into a DNA, then our cells would start to produce that spike, but not the rest of the virus, right? And this is the basic idea behind a genetic vaccine. Take a harmless, but nevertheless identifying part of the RNA of a virus, give it to the body so the body gets acquainted with it, so it starts making antibodies, but give it in a way that is guaranteed to be harmless because it's not enough of the RNA to actually do the damage that the virus does. Now, very quickly, I won't go into this in detail, but Matt Rattel in his wonderful book, An Elegant Defense, and again, I should be careful. I think it's wonderful. I think it's good for non-experts. Maybe experts are wringing their hands about the mistakes he makes, but for me, it was very useful. He, among other things, says that the human immune system is the second most complex system in the human body, right? And it's only second to the brain in terms of its complexity. It has billions of parts. He uses this interesting metaphor. He says that, in essence, the human body contains a festival of life. There are billions of things going on in our body all the time. And it's worthwhile remembering our body depends on the interaction of a whole bunch of cells and bacteria and organs and processes, each of which is independent from each other. And what the immune system has to do is sort all of that stuff from the stuff that is foreign, hostile, pathogenic, right? And of course, that stuff includes a lot of bacteria, which there are also totally benign bacteria in the body. And what we now understand is how complex the human immune system is, that it has erythroblasts and myeloblasts and monoblast cells, including the macrophage cells that eat other cells and create the pus that we all associate with infections. And it's also got the lymphoblast cells. And these are the ones that we need to concentrate on because it contains the B cells and the T cells, as well as the natural killer cells. And the B cells and the T cells are the heart of what's called the adaptive immune system. And the adaptive immune system is adaptive because it can learn. And without going into too much detail here, the process that makes the T cells and B cells has what Rattel calls an infinity machine in it. We make billions of antibodies in order to anticipate the antigens that different pathogens contain, right? And so our body is very well equipped to fight off all kinds of infections. When it gets a new infection that it doesn't have the antibodies for, it has to be fought off in the first instance by the non-adaptive parts of the immune system. And these are the parts that cause fever and inflammation and pain and can ultimately congest the lungs or the heart. And so what you want, what you prefer is an adaptive immune response. And what a vaccine does is teach the T cells and B cells to recognize something that they don't yet have an antibody for, to build the antibody for it, so that if you get infected, your body can have an intelligent, an informed immune response, a precise and targeted immune response, as opposed to bringing out the heavy artillery that does an awful lot of damage to your body at the same time that it fights the infection. Now, the way this works, and I'll try to be brief, is that they take that portion of the messenger RNA and they surround it with lipid nanoparticles, essentially oil, in a way that allows it to enter the body and to then bump into other cells, right? So this would be one of those mRNA oil droplets colliding with a cell in the body. The oil is there to preserve it so that it doesn't get destroyed in the process of entering your body or a cell. Once it's in the cell, it interacts with the mRNA in the cell and produces the proteins, right? Spike proteins, some of which will stay in the cell, some of which will go to the exterior of the cell. And eventually then, a T cell will come along and interact with this cell that has been mutated to encourage it to develop these proteins. And the T cell will then learn and interact with B cells. And the T cells and B cells together will begin to produce antibodies. And those antibodies will then do two things. The first is they will adhere to the spikes on the coronavirus to prevent them from invading cells. And the other thing they will do is direct the T cells, or the subspecies of T cells that are activated killer T cells, to attack the infected cells, the cells where the coronavirus has invaded and is using them to reproduce itself, right? And so that's like a look under the hood for a moment at the way in which the vaccine works. I want to now, as I said, I would move from science and medicine back to politics. And I'm going to start with the issue that we're flying blind at the moment with this mutation, but in general. I'll give you the example of the country that is flying with complete vision. Iceland, small population, so it's easier for them to do, has sequenced the genome of every case of coronavirus in the country. So they know exactly what coronavirus they have. Britain is doing much better. It's why Britain knows that there's a mutation. We have done a few thousand sequences out of a population where we're getting hundreds of thousands of cases of coronavirus a day. You can still count on one hand the number of thousands of people who've had their coronavirus gene sequenced to know what it is. So we just don't know what's out there in our country right now, which makes it very hard for us to understand what kind of coronavirus we're fighting and how it's going to potentially respond to the vaccine in a world in which it may eventually mutate in ways that might make it difficult to work with the vaccine. So this is yet another reason why we need better testing and a different kind of testing. I want to focus for a minute. You may have heard this name, Rochelle Walensky. Joe Biden just appointed her, I think she's from Northwestern University, to be his coronavirus czar. And she anchored a study that's a mathematical model of how the vaccine works in a population. And as I say, we're entering a new era. This is the transition to vaccination era in the coronavirus. And her study is very important. She basically identifies 4 variables as determining how effective a vaccine is in containing the spread of the virus. One of them is the efficacy of the vaccine. We're doing really well there, 95%. But 3 other variables have to do not with the vaccine, but the way in which it's administered and used. So one is rate of transmission. And her study is fascinating. She points out that in a society with an R of 1, so one person is giving the virus to one other person on average, a vaccine with 50% efficacy is going to be more effective than a society where the R is 2 and the vaccine is 90% effective, right? So in order for the vaccine to work, we have to independently be able to control its rate of spread. Similarly, the degree of coverage, that is to say, what portion of the population takes the vaccine, is extremely important for accounting for how effective it is. We need to get up to roughly 70% of the population taking it to prevent it from continuing to be transmitted person to person. It's much more difficult for the vaccine to spread once 70% of the population has developed an immunological response. Finally, she points out that it's not only getting up to 70%, it's how quickly you do it. And that on her model, if it takes a year, that's going to radically undermine the efficacy of the vaccine. Now, the good news is that Joe Biden has just appointed Rochelle Walensky to be his virus czar. And so she will come into the job with a full understanding of this and presumably marching orders to get the rate of transmission down, to get the degree of use up, and to really speed up the dissemination. Because those factors, it turns out, are going to be every bit as important as just how effective the vaccine is. Final couple things to think about here for a moment. One of them is the different approaches to disease containment that we see in the country and the world today. We see generalized population-wide approaches. Everybody should wear a mask. Everybody should socially distance. Everybody should wash their hands. That stuff is easy to do on a population-wide basis. It's not like it's fun to wear a mask, but it's not fun to get the coronavirus either. And I think if you give most people the choice, it's clear which they would choose, right? So there's some things that need to be done by everyone or almost everyone in your society if you really want to bring the rate of transmission down to let the vaccine work. Then there are more targeted approaches where you can focus on a region or a municipality or even a neighborhood. And if you've got good data, if you can tell, the way the South Koreans can, that it's really only in this neighborhood of this city, you can let businesses stay open in other areas and only close them where the virus is active, assuming also that you can do testing, tracing, and containment, right? Which is to say that you get enough people tested, that you get a good picture of where the virus is active and where it isn't active. And you can follow the people who've been exposed to it. And this goes back to that distinction between R and K. And I just want to be clear about this for a moment. The average rate of transmission as opposed to the variability between people in how much they transmit. And what is being learned is that when you do the tracing, oftentimes it's more important to go forward than backwards, right? To go backwards, you could try to figure out where did you get it from. If you go forwards, you try to figure out who have you been in contact since you got it, right? And because it's variable in terms of who transmits and how much, if you can figure out who is likely to transmit the disease and who they've been in contact with since, you can do a really good job at containing the virus without having to have society-wide lockdowns of the kind that is occurring in the south of Britain right now and may very well be occurring in the US soon. Final, obviously, is occurring in places in the US already. Finally, as we enter this transition period, it is going to be extremely important to adhere to public health norms, even after you have been vaccinated, right? So the vaccine protects the whole population only if the whole population has been vaccinated quickly. And so there will be a period when the vaccine is being administered, being given to people where this will not be the case. And so people who have been vaccinated will still potentially be able to transmit the disease, and they have to continue to wear masks, stay distant, etc. During the transition period, the vaccinated may still transmit, and a lot of people around you are not going to be vaccinated. So it's going to be important to maintain those norms. Finally, and this is where I'll stop today, and I think this is extremely important, the rate of mutation in a virus depends on the rate of viral reproduction. Now, that may sound abstract or scientific, but where does the virus reproduce? It reproduces in cells in the human body, right? So it can mutate more quickly if more people are infected. And one of the things that a vaccine does is it drives mutation. It gives the virus that can resist the vaccine a huge adaptive advantage. And so if we don't have 70% of the population vaccinated quickly, it makes it more likely that the virus is going to mutate and mutate in ways that make it resistant to the vaccine. And so if we can get that message out, if it can be understood that you can really see the light at the end of the tunnel, but to get there, everybody needs to be vaccinated and vaccinated quickly, and then demand of our government that it actually facilitate that, we will be in better shape. All right. Do you feel like you just went back to high school biology? I know there was a fair bit of technical stuff. I have a feeling some of you may understand this better than I do. Who wants to start us out? I'm going to unmute everyone. Who wants to start with the question today?
My God.
Sorry?
David, I just feel overwhelmed.
You feel overwhelmed?
By the amount of data.
Yeah, okay.
It's very fascinating. I really appreciate it.
Yeah, I'm doing it for myself to try to understand better the science behind what I'm talking about. I obviously want to do it for you as well. Probably I'm not as good at explaining it as I am stuff that I know better, because then I know how to slow down and unpack. I hope it made some sense, and I hope you're not too overwhelmed by it.
No.
Okay.
I thank you.
Richard, go ahead.
We don't know also how long the efficacy of the vaccine, and that's part of the dilemma also. how
Yeah.
long will it continue being effective?
Yeah, if I've got it right, I think the trials have established 16 weeks so far. And obviously we hope it's a lot longer than that, right? I mean, there's some vaccinations, you get them, 2 or 3 times in your life and you're good. There's some vaccinations that you have to get every year. Some of that is due to mutation. I learned one more interesting thing, which I'll share with you, which is that the rate of mutation in the flu virus is not that much more rapid than in the coronavirus, which is what I originally thought. The issue is that the flu has been around for so long that there are lots of different mutated versions of it already there. Whereas the coronavirus is a novel virus, there are not many mutations around right now. And so that makes it easier to hope, even if we have to be vaccinated once a year, that it won't be as much guesswork in the efficacy of the vaccine for the coronavirus as there is for the flu.
One other follow-up.
Yep.
That if you offer an incentive to get vaccinated, the studies show that that is counterproductive. Because those people who feel that if you have to pay me to take this, there must be something really wrong with this issue. And so it has to be so voluntary to be effective.
Interesting. Yeah, I had not heard that. And that makes sense, but in a sense, it makes it more complicated. I wonder about coercion as well. So there's talk about employers demanding that their employees get the vaccine as a condition of coming to work, and whether that results in wider use or not. Bob, go ahead.
Just one point, given our population who is almost next in line for the virus, the fact that you have to continue to wear a mask and continue to follow all those social norms is very important for us.
Yeah, and to be clear, you will be protected, assuming the vaccine works in the way that it's supposed to work. And please note, there are side effects to the vaccine. It's not pleasant for a certain portion of the population. As I said, wearing a mask is not pleasant, but it's not as unpleasant as getting the virus, which can be deadly or have a lot of morbidity, a lot of pain, suffering, some of it long-term associated with it. So the good news is once you get the vaccine, you'll be much more protected, but you still need to do those things for the sake of other people. Thanks, Bob. Anybody else with a question today? All right, I'm going to take a little break. I have another lecture.
I have a question.
Go ahead. Is that Karen?
Yes.
Doris, go ahead. Doris, you got to hold your spacebar down. Sorry.
You mentioned that a country like Iceland has been able to maintain itself without the pandemic, but has it been without a vaccine? And if so, whatever they've done, has it been mandated by the government, whatever they're doing?
So the example of Iceland is actually a little bit different from that, Doris. What Iceland has done is it has done sequencing on the RNA of the virus for everyone who has contracted. So that it's not that they've succeeded in containing it. I think they're doing a lot better than we are, in part because it's a smaller and less dense country, in part because people are more likely to conform with public health directives. But what they have that we don't have is a really precise understanding of where the virus is and what mutation of the virus is present, right? And that's necessary to have an intelligent and specific response to the virus, to not tell people in Wyoming, you have to shut your businesses when it's not actually that prevalent in Wyoming, when it is prevalent in Tennessee, to be able to say, we're going to tell you to shut your businesses now, not in general, but because we know it's spreading really rapidly here because we have the data. We don't have that yet. And the tracing is separate, but that's also extremely important. Figure out who got it
Isn't
and
that
who they
due to
interact
the- isn't that due to the leadership in the government?
Of course, of course. And we can hope. I guess I hope for two things, and I'll be blunt. One of them is that Joe Biden will be a different kind of president. And the second is that Donald Trump's action in the White House over these last 2 months may discredit him with important portions of the population.
Oh,
So
got it.
it makes it harder for him to continue to do mischief on this issue. All right, everyone. Good talking with you again today. I'll see you in the new year. Best wishes that it's a happy new year, that we're entering into a better one than the one past. Take care, everybody.
Thank you.
Thank you very much and Happy New Year.
Thank you, David.
Thank you, guys.
Bye, David. Thank you.
Bye, guys. Take care.
Bye.
Bye-bye.